Welcome to the Hidden Leaf Village, Shinobi. Today's mission is to solve LeetCode 2537, count the number of good subarrays. In this challenge, we're tasked with counting how many subarrays in a given list have at least k pairs of elements where the first index is smaller than the second, and both elements are equal. Sounds a bit tricky at first, but don't worry, we've got the perfect strategy for this. The team's got your back. Alright, first things first. What exactly is a subarray? A subarray is just a contiguous sequence of elements from the original array. Imagine you're grabbing a few sushi rolls from the platter instead of eating the whole tray at once. For example, if nums is 1, 2, 3, 4, some subarrays are 1, 2, 2, 3, 4, 1, 2, 3, and so on. You get the idea. You pick a slice of the array, and that's your subarray. Let's get our ninja squad ready for action. These ninjas will guide you through the process. We'll use a HashMap to track the frequency of each number in the array. Think of it like Kakashi's ninja notebook, where he writes down everything he needs to remember. The more times we see a number, the more pairs can be formed. To keep things fast, we use the sliding window technique. Instead of checking every subarray, which takes too long, we'll expand the window from the right, like Naruto charging forward, and shrink it from the left, like Sasuke controlling the balance. When the window has enough pairs, we stop expanding and start shrinking to find the smallest valid subarray. Once we find a valid subarray, one that meets the condition of having at least k pairs, we don't need to check each possible subarray inside it individually. We just count them all at once. It's like Hinata, quietly noticing everything without making a fuss. Alright, now that we've got our strategy in place, here's the code that will implement the solution. We start with both the right pointer and left pointer at position 0. The frequency map starts empty, and we're tracking the number of pairs, which is 0 at the beginning. As the right pointer moves, we track the frequency of each number using the HashMap. Every time we encounter a number, we check if it has formed a pair with any previous occurrences. If it has, we increase the pair count. Once the number of pairs reaches the required k, we start shrinking the window from the left side, ensuring we only count valid subarrays. Once we've counted all possible subarrays, we return the result. Alright, now that we've got the code in place, let's dive into an example. We're working with nums equals 3, 1, 4, 3, 2, 2, 4 star, and char k equals 2. Let's walk through the process and see how the algorithm counts the good subarrays. We start with both the right and left pointers at the beginning of the array. The frequency map is empty at the start. The right pointer moves to the first element, which is 3. We add 3 to the frequency map. The map becomes 3 maps to 1. No pairs yet, so we move the right pointer ahead. Next, the right pointer moves to 1. We update the map, 3 maps to 1, 1 maps to 1. Still no pairs, so we continue. The pointer then moves to 4. The map becomes 3 maps to 1, 1 maps to 1, 4 maps to 1. Still 0 pairs, so we move ahead again. Now, the right pointer reaches another 3. We update the map. 3 maps to 2, 1 maps to 1, 4 maps to 1. Now we have 1 pair, 2 threes. The right pointer moves to 2. The map updates to 3 maps to 2, 1 maps to 1, 4 maps to 1, 2 maps to 1. That gives us 2 pairs in total, which matches our target k equals 2. So we've found a valid subarray. Now, we start moving the left pointer to check if we can find smaller subarrays that are still valid. The right pointer moves to the next element, another 2. The map becomes 3 maps to 2, 1 maps to 1, 4 maps to 1, 2 maps to 2. Now we have 3 pairs, which is more than we need. So we continue moving the left pointer to reduce the window size. Finally, the right pointer moves to the last element, 4. The map updates to 3 maps to 2, 1 maps to 1, 4 maps to 2, 2 maps to 2. We now have 4 pairs, and again, we move the left pointer as needed. Each time the condition is satisfied, we count the valid subarrays. By the end, the algorithm successfully calculates the number of good subarrays, and the result is 4 good subarrays. Let's quickly go over the time complexity. Since both the right and left pointers move across the array once, the time complexity is big O of n sus, where n is the size of the array. Each element is handled a constant number of times. For space complexity, we use a frequency map. a hash map to track how many times each number appears. In the worst case, if all elements are different, we store n keys, so the space complexity is also big O of n time. Great work! We've completed LeetCode 2537 and clearly understood how to count good subarrays. If you found this helpful, don't forget to subscribe for more beginner-friendly LeetCode walkthroughs. More problems coming your way? Stay tuned. See you in the next one.